chi-square goodness of fit test in R statistics. Chi-square test is used when there is one categorical or nominal variable. Nominal variable could have two categories in it or two levels, such as male, females, yes or no. Then it is called dichotomous variable. The nominal variable can also have multiple levels in it, and it's called multinomial, such as professions that have 4 levels in it: doctor, dentist, scientist, and nurses. The test can be also used for the analysis of a single ordinal variable. The test will examine whether there is a significant difference between observed frequencies compared to expected frequencies. Here in this slide, a categorical variable for professions in a hospital that have 4 categories in it: doctor, secretary, pharmacist, and nurses. And the number of those cases within each level is gathered and reported, and it was found that the observed frequencies for doctors are 34, for secretary 54, for pharmacists 42, and for nurses 70. And it is hypothesized that the expected frequencies will be of equal proportion, i.e. there is equal percentage of frequencies in each level. So the chi-square goodness of fit test can be used to determine whether there is significant differences between observed frequencies and expected frequencies when there is equal proportion, or it can be also set at specific proportion, such as an unequal proportion, when the expected count can be set at, for the first level, doctors 10%, secretary 20%, pharmacist 30%, and nurses 40%. So for chi-square goodness of fit test, 2 hypotheses are generated: the null hypothesis and the alternative hypothesis. The null hypothesis states that there is no difference between observed frequencies compared to expected frequencies. The alternative hypothesis states that there is a difference between the observed count compared to expected count. A p-value will be generated. When the p-value is less than 0.05, then accept the alternative hypothesis. To perform the chi-square goodness of fit test in R statistics, first of all, to define and label the data and enter the data for the categorical variable, which is in this case the profession. It will be assigned an X value, or the label for this data is X. Then insert the assignment operator, and then cipher combine to generate a vector that has in it 4 counts. The first one is for the doctor, the second one is for the secretary, the third one is for the pharmacist, and the fourth one is for nurses. And this is a count or a frequencies. So with this command, the R statistic will define a data, categorical data, nominal data, give it a label of X, and the data in it is given in frequencies. And if the hypothesis states that there is an equal proportion, then the expected value for each level will be similar. Since we have here 200 cases, then there will be 25% cases for the first level, and second and third and fourth, and that is equal to 50 cases. So insert the command for the expected value by defining the data or the variable, give it a y label, and then assigning operator combine to generate a vector, and set the expected frequencies of an equal proportion. When the hypothesis states that there is an equal proportion, then design a variable, give it a label z, use the assignment operator, use the C for combine to generate a vector, and between two brackets insert the specified probability or proportion for the expected frequencies. In this case, 10%, 20%, 30%, and 40%. To perform the chi-square goodness of fit test for this single categorical variable, use the command chi-squared dot test between two brackets x comma p for proportion, whether you want to use an equal proportion or an equal proportion depending on the stated hypothesis. Here in this R Studio, I'm going to first of all insert the data for the categorical variable, which is the profession, which have 4 levels in it, and then calculate the and determine the value for chi-square goodness of fit test when we have equal proportion or unequal proportion. Insert the categorical variable, give it a label of x, space, assignment operator, space, C for combine, open a bracket, insert the frequencies for each level. So it's going to be 34, 54, comma, and then 42, and finally 70 for the nurses. So whenever a frequency is entered, it has to be followed by a comma. Click on enter, and for the expected frequencies, assign a y label for it, insert the assignment operator, insert C, open a bracket, and then here we want to state that there is an equal probabilities or proportions for the expected frequencies. So we have 4 levels, 200 cases, then it will be 0.25 for each level. So insert 0.25 followed by comma for each level, comma here, and then finally 0.25. Close the bracket and decrease the space here, hit enter. To perform the chi-square goodness of fit test, type chi-squared dot test, and then open a bracket, insert the categorical variable, which is x, comma, and then insert the type in the p, which is the probability that will be equal to y, which is having an equal proportion. And if you click on enter, the chi-square test for goodness of fit is performed, and a value of 14.72 is generated, and a degree of freedom 3, which is equal to n-1. N is the 4 levels or 4 categories within the variable. minus 1 equal to 3, and a p-value is generated of less than 0.05. So this test shows that there is a significant difference between the observed value here compared to the expected frequencies. If we decided to set the expected frequencies at an unequal proportion, then I will generate another vector and another variable, give it a label of z, then use the assignment operator, combine, insert a vector, and then for unequal proportion I'm going to set the expected frequencies for the first category, which is the doctor here, 10%, the second 20, the third one 30, and the fourth one 40. So insert 0.1, 0.2, 0.3, 0.4. Click on enter. Type in chi-square.test, open a bracket, use the first observed variable, which is label, which is x, comma, then p for the proportion will be equal to z, close the bracket, hit enter. The chi-square goodness of fit test is performed or rerun, and a new value is generated under this specification, or for the expected value under this new hypothesis, alternative hypothesis of unequal proportion. The chi-square value is equal to 21.3, and the degree of freedom is 3, and the p-value is less than 0.05, which indicate that there is a significant difference between the observed frequencies compared to expected frequencies when there is an unequal proportion. So this is the way to perform chi-square goodness of fit test in R statistics.